Now, do you know that current, when it flows for a longer period of time, it heats up the conductor?
Hmm.
Yes,
Right.
it heats the conductor, right? Where have you seen the example for this?
Like with the light bulbs.
In the light bulbs, right? So in the light bulb, when the current flows for a longer period of time, you see that in the light bulb, you have, it gets heated up. Okay.
Right.
So, yeah, what happened?
I know I'm saying this, so I just figure it out.
All right. So that means current can heat some object. Current can heat any object, right? Current can heat up objects. So when a current is passing through a conductor, it can heat up the conductor. And do you know the reason why it happens?
No, sir.
No. Okay. So basically, conductors are made up of metals, right?
Right.
And there are metal atoms.
Hmm. Right.
There are metal atoms, right? Now, when there are metal atoms, okay, when there are metal atoms, you should know that current moves. And what is the cause where current moves? What moves inside the metal atom so that current, we say that current is moving?
Electrons.
Very good, electrons. So now what happens when these electrons moving inside the conductor? These electrons are actually colliding with the metal ions.
Okay.
Okay, these electrons are colliding with the metal ion, and when they are colliding with the metal ion, friction arises.
Okay.
Okay, friction arises, and due to this friction, okay, and due to this friction, only you have heat produced. You know that friction can produce heat, isn't it?
Right.
Friction can produce heat. So because of this, heat is produced because of the friction of electrons hitting the metal atom. Okay.
Okay.
So when, and these metal atoms which are present in the conductor are also the reason why resistance develops. Electrical resistance develops. Is that clear to
Oh.
you?
Yes, sir.
Resistance. The electrical resistance develops because of this presence of metal ion. Okay. Basically, what is the meaning of resistance?
How much energy or something? How much electrical input needs to be added
No.
before it can go?
No. What is the meaning of electric resistance? General meaning of electric resistance.
So electric resistance is basically the material's property, like that measures how much it opposes the electric current.
Material property, how much it opposes the electric current, right?
Right.
Now, this opposition to the electric current, this friction is created by the metal ion. And so can I say that when resistance is more, heating effect will be more?
Yes, sir.
So can I say that when resistance is more, heating effect is more,
Right.
right? When resistance is more, heating effect is more.
More.
Okay. So there is a connection between the resistance and the heating effect. There's a connection between the resistance and the
The
heat.
heating.
Okay. So for heating an object, you require what all things? You require current, you require resistance, you require one more thing. Can you guess what it would be?
Voltage.
No. Voltage is response. See, voltage is also there, but it comes in the form of current. But there is one more thing which is very important that is required for the heating effect.
I'm not sure, sir.
Not sure. Okay. Have you ever observed that when current passes in an object for a longer period of time, it creates more heat energy?
Right.
Yes or no? It creates more heat
Yeah.
energy, right? So the third factor that is required is time taken for the current to flow.
Whoa.
Understood? So
Huh.
three things decides the heat energy produced. Current, resistance, and the time taken. Current, resistance, and the time taken. From there only we have the Joule's law of heating, which we are going to see now. Okay?
Okay.
So let me go forward. So now you understood what is resistance. Okay. Now, basically, resistance is a property of a conductor. As you told me, it is measured by voltage by I. It's measured by voltage by I, V by I. All right, it is measured by voltage by I, V by I. So R is equal to V by I. And do you know it's a name of one law? What law is this?
That's Ohm's law.
Very good. It is the Ohm's law. Okay, Ohm's law is R is equal to V by I. Okay, so now actually see, or I can also write like V is equal to IR, right?
Right.
Okay. Now, if I draw a graph between voltage and if I draw a graph between voltage and current, okay. If I draw a graph between voltage and current, okay, how will
Hmm.
the graph look like?
Okay.
How will the graph should be?
Linear. It will be the one on the left.
This one, right?
Uh-huh.
All right. So it should be a straight graph. And
Right.
what will the slope of this graph give me?
Resistance.
Very good. The slope of this graph will give you resistance. But you see that there are different graphs also. There are different types of graphs. Okay. So graph A shows the conductors which obey Ohm's law. Graph B shows lamp filament. Okay. Graph C shows a diode. And graph D shows a thermistor. Okay. And A, B, C, and D, they do not obey Ohm's law. Only A. A is a ohmic conductor, whereas B, C, and D are non-ohmic conductor and they do not follow Ohm's law. Okay. So still here, is it clear to you? Yes or no, Tejas? What happened? Where are you? Are you able to hear me?
Sorry, so for some reason my monitor accidentally disconnected. I had to like push the plug back in.
Okay, okay, okay. So were you able to hear me till now?
Yeah, so we did. Yeah, I heard you.
Okay. So you saw, right, the ABC graphs?
Right. Yeah.
Yeah, you heard about the graph, right? B, C, D does not follow Ohm's law.
Right.
Okay, fine. Now, I will be telling you about what resistance depends on. Okay.
Okay.
Ohm's law gives us the relationship between current and voltage. Okay.
Okay.
But resistance also depends on some of the geometrical aspect of the conductor. Okay, it depends on some of the geometrical aspects of the conductor. And those aspects are, yeah, I'll say that the resistance is proportional to the length of the conductor. That means when you have a longer length of a conductor, the resistance will be more. Okay.
Okay.
Second thing, resistance depends upon the uh, what do you call resistance depends upon the uh, resistivity of a conductor. Okay. And
Okay.
resistivity is a constant. Resistivity is a constant. Okay, so different material will have different resistivity value. Okay, different material will have different resistivity value. So copper might have a different resistivity value. Aluminum will might have a different resistivity value. Okay, and
Okay.
also resistance depends is inversely proportional to A. Okay,
Okay.
resistance is inversely proportional to A. What is A? A is the cross-sectional area. Okay,
Okay.
now that's why resistance is equal to, so when you put all this in equation, resistance is equal to rho L by A. Resistance is equal to rho L by A. Is that clear to you?
Yeah, so
All right.